Hi, I'm John Williams, and I'm going to talk about my project, which is 3D Caustics. You may be familiar with red and cyan images for 3D glasses, also called anaglyphs. I came up with a method for creating these anaglyphs without the use of a computer or even a camera. The method is to simply cast shadows using two light sources, one red and one cyan. So here's my simple setup, and underneath there are two LEDs, and they're just wired in parallel, and they're extremely bright. They're a lot of lumens, and this right here is the batteries, which you can see, and that was actually just from a flashlight that I took apart, and then I used the textbooks just to block everything up to get the right distance. And then I put the 3D glasses on top, and the reason for that is it filters the light to be consistent with the glasses that you're wearing, so that I didn't have to worry about getting LEDs that were exactly the right shade of red and exactly the right shade of cyan. Then up here I have a little tank which I made out of acrylic and this special solvent glue I found on the internet, and it's called Weld On 4, and it's full of water. Also plenty of transparent toys to play with. And the frame is actually part of a shelving system which was in my basement going unused, and I thought, how convenient. To understand why this works, consider that shadows and perspective vision are the same type of projection. Each of the two light sources is projecting what a single eye should see, and the 3D glasses ensure that the correct eye sees the correct projection. Whether you wear the blue lens on your right side or your left side, as well as the side of the tank that you stand on, will affect how you perceive the objects. There are two aspects of the 3D image. One is the depth from your eyes seeing two different things, and the other is the size of the object. If the blue source of light is on the same side as the blue lensed eye, then the perceived depth of the object will be mirrored from its actual orientation. However, an object perceived to approach you will get larger, as it should. If instead the red source of light is on the side of the blue lensed eye, then the perceived orientation of the object will be the same as in reality, but as it appears to approach you, it will get smaller instead of larger. You may be able to view the video in 3D glasses, but the effect is strongest in person. For ideal viewing, the position of your eyes should be the position of the LEDs mirrored across the plane of the paper. In fact, the LEDs are exactly an eye width apart, so that they can be the mirror image of your eyes. I chose LEDs instead of other light sources because they are like point sources and are capable of casting very hard shadows. If you were to watch the video over again, but with the lens colors flipped on your face, then you would perceive everything in reverse. This project was done for a class called Light Art at my school, WPI. There will be no more speaking for the rest of the video.